I am Dr. Suresh from School of Mechanical Engineering. Today we will discuss second topic on Unit 2, balancing of different masses rotating in the same plane. So in the course Dynamics of Machine, subject code for this course is BTME3008. We already familiar in this following cases, balancing of single rotating mass by single mass rotating in the same plane. For example, balancing a single rotating mass, so another mass is provided in the same plane in order to counteract the centrifugal force produced by the first mass. So this case is called as a balancing of single rotating mass by single mass rotating in the same plane. The second case is balancing of single rotating mass by two masses rotating in the different planes. Means that for balancing a single rotating mass, two different masses are added in the different planes in order to balance the first mass. So the high-speed engine and other machines is equipped with the rotating and reciprocating parts. So these rotating and reciprocating parts are to be balanced as far as possible. If the parts are not properly balanced, the dynamic forces are set up. So these forces not only increases the load on the bearings and stresses in various members, but also produce unpleasant and very dangerous vibrations. So because of this unbalanced forces, this will create maximum vibrations in the IC engine. The balancing of unbalanced forces caused by the rotating masses. So this topic we are going to discuss in detail in this lecture. Whenever a certain mass is attached to the rotating shaft, it exerts some centrifugal force, whose effect is to bend the shaft and to produce vibration in it. In order to prevent the effect of centrifugal force, another force is attached to the opposite side of the shaft at such a position so as to balance the effect of centrifugal force of the first mass. This is done in such a way that the centrifugal force of both the mass are made to be equal and opposite. The process of providing the second mass in order to counteract the effect of the first mass is called as balancing of rotating mass. For example, so this line is indicating this axis of rotation, axis of rotations. In the axis of rotation, so there is another one mass is there. That mass is m2, which is denoted by m2, which is at a distance of r2 from the axis of rotations. So when only this m2 mass is attached to the rotating shaft, when this mass is rotating, then outward force will be exerted from the m2 mass. So that force is called as a centrifugal force. So this centrifugal force create the bending action on the shaft. So in order to counteract that, so we are adding that another mass, that is a disturbing mass in the same plane of this m2 mass. So the disturbing mass also will produce the centrifugal force. So that centrifugal force, which will be equal and opposite to the balancing mass. So the system is in the balancing state. So this is the process of providing the second mass, that is the disturbing mass, in order to counteract the effect of centrifugal force of the first mass, that is a balancing mass. So this process is called as balancing of rotating masses. Now we'll see the balancing of several masses rotating in the same plane. Consider any number of masses, say 4, of magnitude m1, m2, m3 and m4 at a distance of r1, r2, r3 and r4 from the axis of rotating shaft. So let us consider a point O. So from the horizontal axis, so we are considering the 4 masses. The first mass is m1, which is at a distance of r1 from the axis of rotations. The position of this m1 plane is m1 mass is at theta 1 from the horizontal axis. So similarly, the second mass is m2 is located at a distance r2 from the axis of rotation. Then angle between the m2 mass and the horizontal line OX is theta 2. Then third mass is m3 is located at a distance r3 from the axis of rotation. at an angle of theta 3 from the horizontal axis OX. Then fourth mass is, that is M4, is located at a distance R4 from the axis of rotation at an angle of theta 4 from the horizontal axis OX. Let these masses rotate about an axis through O and perpendicular to the plane of paper with constant angular velocity of omega radian per second. The magnitude and direction of the balancing mass can be found out by using analytical method. So let us see how to find out the magnitude and direction of the balancing mass with the help of analytical method. First step is find out the centrifugal force, that is the product of mass and its radius of rotation exerted by each mass of the rotating shaft. So this is the first step. So we have to find out the centrifugal force for the each mass. The second step is resolve the centrifugal force horizontally and vertically. Find their sums. Sum of horizontal forces and sum of vertical forces we have to find out. So if you see in the space diagram, each masses is located at different angles. Whenever a mass is making an angle with respect to horizontal axis or any of the vertical axis, so the force is having the two component. One is horizontal component, another one is a vertical component. So what we are doing, just we are resolving the forces along the horizontal components and also resolving the forces along the vertical component for all the masses. So we are doing that same thing. We are resolving the forces along the horizontal axis and also resolving the forces along the vertical axis. Then we are summing up the horizontal component of all forces, that is sigma h equal to m1 r1 cos theta 1 plus m2 r2 cos theta 2, and the sum of vertical components of the centrifugal force sigma v equal to m1 r1 sin theta 1 plus m2 r2 sin theta 2. Similarly for other mass also we have to add the vertical component. After finding out the sum of horizontal component of forces and sum of vertical component of forces, the magnitude of resultant force is calculated by using the formula Fc equal to square root of sigma h square plus sigma v square. This is the formula for calculating the magnitude of the resultant centrifugal force. If theta is the angle which the resultant force makes the angle with horizontal, then tan theta equal to sigma v divided by sigma h. So where sigma v is the sum of vertical component of forces and sigma h is the sum of horizontal component of forces. So by the help of this formula we can find out angle of inclination of the resultant force with respect to horizontal. The balancing force is then equal to the resultant force but in opposite directions. Now find out the magnitude of the balancing mass Fc equal to m into r. So where m is the balancing mass and r is radius of rotations. Now we already determined this Fc, that is a resultant force we already determined. Just we have to substitute the resultant force here in place of centrifugal force equal to m into r. So where m is the balancing mass, r is radius of rotation of the balancing mass. Then radius of rotation, if it is given in the problem, then m is unknown, so we can find out the magnitude of the balancing mass by using this formula. The second method is a graphical method which is used to find out the magnitude and position of the balancing mass. First of all, draw the space diagram with the position of the several masses. For example, OX is the horizontal line. So with respect to horizontal lines, we are locating all the masses. So based on the given angle. So theta 1 will be given in the problem itself. Based on theta 1, just we are locating the mass 1. Similarly, for mass 2 is located with the help of theta 2, then mass 3 with the given value of theta 3, and mass 4 with given value of theta 4. So like that, so we are drawing the space diagram. So after drawing the space diagram, then we have to go for find out the centrifugal force exerted by the each and every masses. We know the formula for centrifugal force, Fc equal to m into r. So for similarly for each and every masses, we have to find out the centrifugal force. Now draw the vector diagram with the obtained centrifugal force such that AB represents centrifugal force exerted by the mass m1 in magnitude and direction to some suitable scale. Just we have to consider a point A. From A point we have to draw the vector, that is Fc1. The value for Fc1 equal to m1r1. So based on that formula, so we have to calculate the value for Fc1 and we have to draw the vector AB. So vector AB is inclined to the horizontal at an angle of theta 1. So AB angular position is similar to the angular position of mass 1. Similarly, draw BC, CD and DE to represent the centrifugal force of other masses M2, M3 and M4. So similarly, we have to draw the BC, CD vector and DE vector. So we are having that 4 centrifugal forces Fc1, Fc2, Fc3 and Fc4. For each and every mass we are having we know the angular positions. So based on that angular positions we are locating these vectors Fc1, Fc2, Fc3 and Fc4. Now as per the polygon law of forces, the closing side AE represent the resultant force in magnitude and direction. The balancing force is then equal to the resultant force but in opposite in directions. So this balancing force, so we'll get the resultant force like this. The balancing force is equal to the resultant but in opposite directions. So in this space diagram, if we consider m1, m2, m3 and m4 are the given masses. For these 4 masses we are having 4 centrifugal forces. The resultant of all the four centrifugal forces will have the resultant force will be acting in these directions. Then the balancing mass is equal and opposite to the resultant force. Here this is the balancing mass. Now find out the magnitude of the balancing mass m at the given radius r such that m omega square r equal to resultant centrifugal force. So which will be again rewritten as mr equal to resultant of m1 r1, m2 r2, m3 r3 and m4 r4. So we know that resultant force here, just substitute the resultant force value here and the radius of the resultant also we know. Then from that we know we can calculate the magnitude of the balancing mass. Now we see one problem on balancing of several masses rotating in the same plane. So let us see the problem. 4 masses M1, M2, M3 and M4 are 200 kg, 300 kg, 240 kg and 260 kg respectively. The corresponding radii of rotation are 0.2 meter, 0.15 meter, 0.25 meter and 0.3 meter respectively. And the angle between the successive masses are 45 degree, 75 degree and 135 degree. Find the position and magnitude of balance mass required if its radius of rotation is 0.2 meter. So this is the problem. From this problems, these are the given data. M1 equal to 200. There are 4 masses are there. M1 equal to 200 kilogram, M2 equal to 300 kilogram, M3 equal to 240 kilogram, M4 equal to 260 kilogram. So each and every masses is located at corresponding radii, that is R1 equal to 0.2 meter, R2 equal to 0.15 meter, R3 equal to 0.25 meter and R4 equal to 0.3 meter. So these are the masses, and corresponding the radius of rotation of the masses are given as R1, R2, R3 and R4. The angular position of each and every masses is given as, that is theta 1 equal to 0 degree from the horizontal line, and theta 2 equal to 45 degree, theta 2 equal to 45 degree, and theta 3 equal to 45 degree plus 75 degree equal to 170 degree. That is the angle made by the mass 3 from the horizontal line, that is that angle is 120 degree. Similarly, for theta 4 equal to 45 degree plus 75 degree plus 135 degree equal to 255 degree. That is angle made by the fourth mass with respect to horizontal line. So this is a M1 mass equal to 200 kilogram, which is located at radius 0.2 meter. This is M2 mass of 300 kilogram. So at a radius of 0.15 meter at an angle, that is theta 2 equal to 45 degree. This is M3 mass, that is M3 equal to 240 kilogram. So at a distance of 0.25 meter, then angle made by the M3 with respect to the horizontal masses, that is theta 3 equal to 120 degree, and this one is M4 mass, that is M4 equal to 260 kilogram located at distance of 0.3 meter from the axis of rotation and at angular position of, that is theta 4 equal to 255 degree. So these are the four masses which will be present in the single plane. For balancing these four masses, we have to provide one balancing mass. So that mass we have to find out what is the magnitude of the balancing mass. Then the radius of location of the balancing mass, that is R 0.2 meter, that is given in the problems. So the radius of location of the balancing mass from the center of axis of rotation, that is R equal to 0.2 meter, which is given in the problem. So as per the problem, we have to find out how much balanced mass is required, that is the magnitude of the balanced mass we have to find out. As we know, m is the magnitude of the balancing mass and r is the radius of location of the balancing mass. Let theta is the angle which the balancing mass makes with mass 1, that is with the horizontal axis. The magnitude of centrifugal force are proportional to the product of each masses and its radius. Therefore, M1 R1 equal to 200 into 0.2 equal to 40 kilogram. Centrifugal force for the second mass is calculated, that is FC2 equal to M2R2 equal to 300 into 0.15, which will be equal to 45 kilogram meter. The centrifugal force for the third mass F3 equal to M3R3 equal to 240 into 0.25 equal to 60 kg meter. Then centrifugal force for the fourth mass, that is FC4 equal to M4R4 equal to 260 into 0.3 equal to 78 kilogram meter. So this is a case. So centrifugal force is calculated for all four masses. The problem may be solved either analytically or graphically. So first we'll see how this problem is solved through analytical method to determining the magnitude of the balancing mass. Now we see the analytical method to find out the magnitude of the balancing mass. The centrifugal force of all masses are resolved into horizontal component and vertical component. Sigma h is the summation of horizontal component of forces which will equal to m1 r1 cos theta 1 plus m2 r2 cos theta 2 plus m3 r3 cos theta 3 plus m4 r4 cos theta 4. After substituting m, r and theta values, then we'll get that sigma h equal to 21.6 kg meter. That is horizontal component forces equal to 21.6 kg meter. Now resolve the forces vertically, that is summation of vertical component of forces equal to m1 r1 sin theta 1 plus m2 r2 sin theta 2 plus m3 r3 sin theta 3 plus m4 r4 sin theta 4. Substitute the value of m1 r1 theta in the sigma v equation, then finally sigma v equal to 8.5 kg meter. Here we have find out the summation of horizontal forces and summation of vertical forces. Now we have to calculate the resultant force R equal to square root of sigma h square plus sigma v square. So in this equation, the sigma h and sigma v value we have to substitute. Once after substituting, resultant force will be determined. So that is 23.2 kilogram we will get as per this problem. There is a formula is there, resultant force R equal to m into R. So when we know the value of R, that is 23.2, substitute this formula. After substituting, then we can determine the magnitude of the balancing mass. M equal to 23.2 divided by R. So R is nothing but the radius of location of the balancing mass, that is 0.2 meter. So this value also substituted and the magnitude of the balancing mass is determined, that is m equal to 116 kilogram. Then theta dash is determined by using the formula tan theta dash equal to sigma v divided by sigma h. So theta dash is nothing but the angle of location of the resultant force, We know the value of sigma v and sigma h. Just we are substituting the sigma v and sigma h in this equation. Finally, we can get this tan theta dash equal to 0.3935. So from this equation, theta dash will be obtained as 21.48 degree. So theta dash is nothing but angle made by the resultant force with respect to the horizontal line. Since theta dash is the angle of resultant R from the horizontal mass of 200 kg, therefore the angle of balancing mass from the horizontal mass of 200 kg equal to theta equal to 180 plus 2148 degree, which will be equal to 201.48 degree. So this is the angle of location of the balancing mass from the horizontal mass. So we know that always the balancing mass will be present just opposite to the resultant force. So that's why just we are adding 180 degree to the angle made by the resultant force with respect to the horizontal mass. Now we will see the graphical method for finding out the magnitude and position of the balancing mass. The step number 1 is, first of all, draw the space diagram showing the position of all the given masses. So this is a space diagram as per the given data. So we have to locate all the masses, that is m1, m2, m3, m4 based on the given angle theta 1, theta 2, theta 3 and theta 4. The step number 2 is the centrifugal force of each mass is proportional to the product of mass and radius. So this is the formula for calculating the centrifugal force. For each mass, centrifugal force is calculated, that is m1 r1, m2 r2, m3 r3, m4 r4. These are the centrifugal forces of 4 masses. And after substituting the value of m and r value in this equation, we get the centrifugal forces for the 4 masses, that is 40 kg meter, that is 45 kg meter, 60 kg meter and 78 kg meter. After calculating the centrifugal forces of all masses, the vector diagram is drawn, that polygon diagram is drawn. We are drawing AB vector, so we know the magnitude of the centrifugal force of mass 1. So based on that, that is a 40 kg meter. So based on that, we are drawing the horizontal vector AB, and then BC also drawn. So based on the values of centrifugal force of second mass and theta 2 value, and vector CD also drawn. So based on the centrifugal force of third mass and theta 3 values, and vector D is drawn based on the centrifugal force of fourth mass and theta 4 values. So as per that, this polygon diagram, this polygon has to be closed. So the closing A is closing side of the polygon. The vector direction is like this. This is the vector direction which will represent the resultant force for the all four forces. The balancing force is equal to the resultant force but in opposite in direction. The balancing mass force is equal to the resultant force but in opposite to that of the resultant force. Since the balancing force is proportional to m into r, therefore m into r value is nothing but 0.2, which will be equal to vector EA. So by measurement, vector EA will get 23 kg meter. So after substituting this vector E value, finally we will get that the magnitude of balancing mass m equal to 115 kilogram. By measurement, we also find the angle of inclination of the balancing mass from the horizontal mass of 200 kilogram. So that is theta equal to 201 degree. The questions based on this lecture is, what is meaning for balancing of different masses rotating in the same plane? Then how the magnitude of balancing mass and position of the balancing mass can be determined using analytical method. Then third question is, how the magnitude of the balancing mass and position of the balancing mass can be determined by using graphical method. And we know how to solve the problems based on balancing of different masses rotating in the same plane. So these are the textbook and reference book for the today's topic. So textbook SS Ratan is used for reference book RS Kurmi and Gupta, A. Ghose, then Thomas Williams. So this book can be referred for this today's lecture topic. I hope everyone understood the balancing of rotating masses in the same plane, then how to find out the magnitude and position of the balancing mass when the mass is rotating in the same plane. So thank you very much for listening the session.